Students, in the current topic, we shall study about the effect of temperature on resistance. In order to study the effect of temperature on resistance, substances are classified into three categories. Number one, conductor. Number two, alloys. Number three, semiconductors. Number one, conductor. In case of conductor, resistance increases with rise in temperature. Experiments shows that change in resistance is directly proportional to initial resistance of the conductor as well as change in temperature. If R1 is the resistance at T1 degree Celsius, R2 is the resistance at T2 degree Celsius, then students R2 minus R1 is proportional to R1 T2 minus T1. To remove the proportionality constant, we introduce to remove the proportionality sign, we introduce proportionality constant. That's why R2 minus R1 is equal to alpha R1 T2 minus T1. Alpha is called temperature coefficient of resistance, which is defined as ratio of change in resistance to initial resistance when the temperature of the conductor is increased by 1 degree Celsius. Temperature coefficient of resistance is a scalar quantity and its SI unit is Kelvin power minus 1, or we can also write degree Celsius power minus 1. Suppose the temperature T1 is equal to 0 degree Celsius and T2 is equal to T degree Celsius, then the equation R2 minus R1 is equal to alpha R1 T2 minus T1 is converted to RT is equal to R0 1 plus alpha T. Now alloys. In case of alloys, the effect of temperature on resistance is negligible, or we say there is no effect of temperature in case of alloys. Due to this property, alloys are used to make standard resistances. Now it comes your semiconductor. Students, in case of semiconductor, resistance decreases with increase in temperature. For semiconductors, the value of alpha is negative. So we can write R2 is equal to R1 1 minus alpha T2 minus T1.